Hello dear friends, welcome to BYJU'S Exam Prep, the comprehensive learning preparation app for your competitive examinations. Now you can learn important concepts of GATE through this Coffee with Concept series. In today's session, I am going to discuss bubble sort. Before that, this is about me, myself Sridhar Dhulipala. I am having 20 plus years of teaching experience and I am associated with BYJU'S from past 2 years. Dear friends, with BYJU'S you are having double advantage. That is recorded GATE content as well as live video sessions. Under BYJU'S Exam Prep, under the category Learn with Video Lessons, you can find all these subject videos which were recorded by me. Engineering mathematics for all the branches, whereas for computer science students exclusively discrete mathematics, algorithms, C programming and data structures. You can join my Telegram group CS_Sridhar to get regular updates about my classes. You can also join my Facebook as well as Instagram pages here. Now let us see how bubble sort works. Bubble sort uses multiple passes या तो scans through an array. That is, it is going to scan an array multiple times. In each pass, bubble sort compares the adjacent elements. And whenever the adjacent elements are in the wrong order, it will swap the two elements. So, in each pass, bubble sort bubbles down the next largest element to its correct position. Because it bubbles down the next largest element to its correct position, it is named as bubble sort. That is the name of the sorting algorithm, my dear friends. Let us try to understand with a simple example. So here we are having an array of size 6. So we are going to have 6 minus 1, that is 5 passes. In each pass, you are going to scan the array, and whenever you find two elements in the wrong order, you are going to swap the two elements. See, in the first pass, you are going to consider first 5 elements and each element is compared with its next element. In the second pass, you are going to consider first 4 elements. Each element is compared with its next element. If they are in the wrong order, we are going to swap the elements. So you continue like this. In the ith pass, you are going to consider first n minus I elements. Each element is compared with its next element. And whenever there is a wrong order, what is the wrong order? If suppose you consider j as the variable used to scan the array, if the value at jth position is larger than value at j plus 1th position, then you are going to swap the two elements. That is, aj is swapped with aj plus 1. So this is the main logic, my dear friends. So let us start with this example. We are having this particular array of size 6. First pass. So this I will represent the pass number, my dear friends. I is equal to 1. That is first pass. J varies from 1 to n minus 1. So j starts with 1 and j value is compared with, that is value at j is compared with value at j plus 1. Okay. That is 10 compared with 40. So we are talking about value at j and value at j plus 1. Okay. So 10 compared with 40. 10 is not larger than 40. So just increment j. Again value at j compared with value at j plus 1. That is 40 compared with 50. Is 40 greater than 50? No. J incremented. Value at j. That is 50 compared with value at j plus 1. That is 50 compared with 60. 50 greater than 60? No. J incremented. Now here 60 greater than 30. That is value at j is greater than value at j plus 1. Immediately swap the two elements. That is, these two elements are swapped. Okay. So now this is the situation. J you increment it. Now j is equal to 5. Again j is compared with, that is value at j is compared with value at j plus 1. Is 60 greater than 20? Yes. Again, there is a swap. See, if you observe, ultimately what happened in this particular pass, the largest element is 60. 60 bubbles down to the last position. Am I clear? So, first pass is completed. And you see 60 takes its correct position. And if you observe, the last element is sorted. The remaining 5 elements need to be sorted now. 60 is in its correct position. You don't have to sort it again. So next time you need to consider only first 5 elements. That is, in the next pass, we need to take j up to n minus 2 only. Am I clear? So the 60 is already sorted. Now again j starts with 1. Value at j compared with value at j plus 1. Is 10 greater than 40? No. J incremented. Is 40 greater than 50? No. J incremented. Is 50 greater than 30? Yes. There is a swap. Again j incremented. Okay, j is now 4. 50 greater than 20. See, it is already sorted. You need to remember. That's why you are going only up to n minus 2. That's why you are going in this particular pass up to n minus 2. You don't have to go up to n minus 1. Even if you go, nothing will happen, sir. But not necessary. Because anyhow, this number cannot dominate 60. So you don't have to go till n minus 1. So 50 is greater than 20. Yes, swap the elements. Now you see 50 bubbled down. And it takes its correct position. So the last 2 elements are swapped. So from here it is sorted. 50, 60 are sorted. First 4 elements need to be sorted. Now in the pass 3, j varies from 1 to n minus 3. Only up to n minus 3 it varies. So you start j is equal to 1. 10 is greater than 40? No. J is equal to 2. Is 40 greater than 30? Yes. Swap the 2 elements. J is equal to 3. Is 40 greater than 20? Yes. Swap. Now you reached the position. Done. Because you are going to take j up to n minus 3. Because n is equal to 6. 6 minus 3. You stop. Because j reached the last position. Done. See, you observe 40 in its correct position. The last 3 elements are sorted. You just need to continue the process, my dear friends. Fourth pass, I is equal to 4. J varies from 1 to n minus 4. That is 1 to 2. Okay, first 2 elements. J is equal to 1. Is 10 greater than 30? No. Increment j. Is 30 greater than 20? Yes. There is a swap. Now 30 occupies its correct position. Fourth pass completed. And the last pass. The last pass, I is equal to 5 and j varies up to n minus 5. That is, j is only 1. J can take only one value, that is j is equal to 1. 10 greater than 20? No. So 20 in its correct position. Now if you observe, because all these are sorted, this is obviously smaller than that. So obviously 10 is also sorted. And the array is sorted, my dear friends. Array is sorted. So if you simply see the pseudo code for this, bubble sort, I varies from 1 to n minus 1. So I will tell you how many passes you are going to do. Obviously n minus 1 passes. And here j varies from 1 to n minus I. And each time what you are going to do, you are going to compare aj with aj plus 1. And whenever aj is greater than aj plus 1, immediately do the swapping. Suppose if aj is less than or equal to aj plus 1, no swapping, sir. Even equal to also, no need of doing any swapping, my dear friends. And you continue for n minus 1 passes. Okay, so if you want to see, you can just verify this. Using the summation notation, you can verify I varies from 1 to n minus 1 and j varies from 1 to n minus I. Each time you are having single statement. It can be easily verified that it is of order n square, my dear friends. So the complexity of bubble sort algorithm is theta n square. Now suppose I'll give you one simple example. Let us consider this array 1, 2, 3, 4. If you take the first pass, When you compare 1 with 2, no swapping, 2 with 3, no swapping, 3 with 4, no swapping. That is, there is no swapping. Okay, because that is already sorted. But if I use the same algorithm which I given, I need to do the entire work. That is, worst case also I'll get the complexity theta n square. What we need to understand is, in a particular pass or a scan, if there are no swappings happening, that means the array is sorted. This gives you one small idea to modify the bubble sort. That is, we can modify the bubble sort. How? We just use one special variable called, this is your old algorithm. We use a special variable called flag variable. We initialize to 0. Now in a particular pass, if there are no swaps happening, you can stop the process. Suppose if the swap is happening, you can update flag as 1. Now if flag is 1, you have to continue the process. But if flag is 0, there is no need of continuing the process. Am I clear? You can just stop the process. You can just return okay, you can just return or come out of the loop, my dear friends. So we can modify the bubble sort. So if the array is sorted, what happens? After the first iteration, you come out of the loop. So we can get the time complexity of the bubble sort theta n if you modify this algorithm. Am I clear? So that is about your bubble sort algorithm, my dear friends. It's a very simple, okay, sorting algorithm having worst case complexity theta n square, and you can modify the bubble sort algorithm so that it can work in theta n time for sorted array. So this is about your bubble sort. In the next session, we take one more interesting concept. Thank you.